Okay, so now we're into the third video of the day, and I think I'll be able to make this the last video of the day. Graphing linear equations using the intercepts, both the y-intercept and the x-intercept. Now, intercepts occur when the other guy is 0. So, for example, this is a picture of the x-intercept here. The x-intercept is 2, because when the y is 0, which means that you're on the opposite axis. If the y is 0, you're on the x-axis. If the x is 0, you're on the y-axis. So whenever x or y is 0, you're on the opposite axis. If y is 0, you're on the x-axis. If x is 0, you're on the y-axis. So at the point 2, 0, the x-intercept is 2. Okay? So that's a picture of using an x-intercept. Now, what we want to do is understand that it's really quick to graph a line if we just substitute 0 for both the x and the y, and then we find the intercepts and we draw a straight line through the two intercepts. So I'll show you what I mean by that. I want to find the x and the y intercepts of the line 2y plus 3x is equal to 6. So the first thing that I do is I substitute a 0 for x. So here's my equation, 2y plus 3x is 6. But instead of writing 3x, I put 3 times 0. 3 times 0 is just 0. So I get 2y equals 6. It's really quick math. Dividing by 2, the y-intercept is 3. The y-intercept is 3 because the x is 0. Remember, if the x is 0, you're finding the y-intercept. If the y is 0, you're finding the x-intercept. Speaking of which, let's substitute 0 for y. I put in a 0 for y. 2 times 0 is just 0, so that whole term disappears just like in the previous problem. 3x is 6, dividing by 3x is 2. So the x-intercept is 2. So the y-intercept is 3, the x-intercept is 2. Y-intercept is 3, x-intercept is 2. So I come over here, the x-intercept is always on the x-axis. The y-intercept is always on the y-axis. So I'm just going to touch it 3 on the y-axis and 2 on the x-axis. There's 3 on the y-axis, there's 2 on the x-axis, and I draw a line through them. That's it, I'm all done. So graphing with x and y intercepts is just a matter of substitute 0 for x, that gets you the y-intercept. Substitute 0 for y, that gets you the x-intercept. Mark the points on the graph, connect the dot. Simple as that. You try the next one. Okay, so I'm sure you did stop and start. So the first thing we want to do is we want to find the y-intercept, and to do the y-intercept, I put a 0 in for x. And so let's just do that part. Finding the y-intercept, I put a 0 in for x, there it is. 3 times 0 is 0, 4y equals negative 12. Oh, the y is equal to negative 3, dividing by 4. And if I want to find the x-intercept, this time I put the 0 in for y. Remember, it's always opposite. You want the y-intercept, 0 for x. You want the x-intercept, 0 for y. So I want the x-intercept now. I know my y-intercept is negative 3. X-intercept is on the x-axis, y-intercept's on the y-axis. As soon as I find out that the y-intercept is negative 3, I go down and I touch it negative 3 on the y-axis. Now, for the x-intercept, I put a 0 in for y. 3x is negative 12. Dividing by 3, x is negative 4. So I go in and I touch it negative 4 on the x-axis. Draw the line that connects the two. And I've got it drawn. Okay? So remember, when you graph by intercepts, plug in a 0 for x, tells you the y-intercept. Plug in a 0 for y, tells you the x-intercept. Mark the intercepts on each of the respective axes. Draw the line to connect them. Okay? You try this one. All right, so first I want the y-intercept. So I'm going to substitute 0 for x. Doing the math, 2y minus 0 equals 12. 2y is 12. Y-intercept is 6. Substitute 0 for y. 2 times 0 minus 4x is 12. 2 times 0 is just nothing, so 12 divided by negative 4 is negative 3. The x-intercept goes on the x-axis. The y-intercept goes on the y-axis. So what I do next is I touch for 6 on the y-axis and negative 3 on the x-axis. There's my 6 on the y-axis. There's my negative 3 on the x-axis. And I just connect the dot and the line is drawn. Okay? Try this one. Little stop and start. Okay, so remember our strategy. Plug in a 0 for the y, that gives me the x-axis. Plug in a 0 for the x, that gives me, I said y-axis, y-intercept. Plug in a 0 for the x, you get the y-intercept. Plug in a 0 for the y, you get the x-intercept. So, plugging in a 0 for x, I get y-intercept of 2. Plugging in a 0 for y, I get an x-intercept of -5. X-intercept goes on the x-axis, y-intercept goes on the y-axis. There's my x-intercept of -5. My y-intercept should be 2. Connect the dot. All done. Okay? All right. Now let's try this one with x and y intercepts. Go ahead. Okay? So, again, same thing every time. You want the y-intercept? Throw a 0 in for x. You want the x-intercept? Throw a 0 in for y. In this case, if you throw in a 0 for x, it works out that the y-intercept is 0. If you throw in a 0 for the y, it works out that the x-intercept is 0. Now, this is a problem because you only have 1 point for both of them. Both intercepts are 0, 0. So you have to find another point. Anytime you get the same y and x intercepts, you got to find another point. So instead of plugging in a 0, plug in anything you want, but I'm going to plug in a 2 for x. So if I plug in a 2 for x, I get y minus 2 times 2 is 0. 2 times 2 is 4, so y minus 4 is 0. And that means that when x is 2, y is 4. Just like doing tables, it's like finding 1 point on a table instead of 5 of them. And then that gives me the point 2, 4. X-intercepts on the x-axis, y-intercepts on the y-axis. And when it's the same intercept for both, you got to go to this technique where you pick another value for x or y, it doesn't matter, and you find the missing value. Now I plot 2, 4, and I connect the dot. Okay? 2 points determine a line, guys. So I got to find the second point. When they're both 0, that means that's 1 point. I need a second point. All right, let's try this one. This is our last one with x and y intercepts for the day. So as we've said many, many times, you want the y-intercept, substitute a 0 for x. You want the x-intercept, substitute a 0 for y. And what you notice is, in this particular case, the y-intercept works out to be 0. So does the x. You know what that means. You're going to get a dot right at the origin where the two axes meet. So I need another point. So I don't care what you plug in there, but pick either one. I'm going to try plugging in a 2 for x. 6 times 2 is 12. 2y plus 12 is 0. Subtracting the 12, dividing by 2, I get y is -6. One more time. Subtracting the 12, I get 2y is -12. Divide by 2, I get y is -6. I was running out of room, so I kind of squeezed it in verbally, so to speak. There's my x-intercept is on the x-axis. Y-intercept is on the y-axis. There's my 0, 0 point. And now I need 2, -6, which is down there. And I connect my dot, and I am all good. Okay? Now, there's one last special case to go over, and that is the case of graphing a horizontal or a vertical line, considering y equals mx plus b. Now, what if you wanted to graph the line x equals 5? Now, that's really weird already because it doesn't say y equals like every other line that we have done so far says. So since it says x equals, I know I'm getting into the realm of the weird, the little bit different. Whenever it says x equals a constant, you get a vertical line. And the reason for that is because there is no slope. See, the slope is the angle of the line, like where you would walk up the line. You go up so many, over so many, up so many, over so many. You can't do that when it's x equals 5 because you can't go over at all. You're just going up or down. You can't go over, and there's nothing to walk up. There's no slope to walk up. You would fall right off the side of a vertical line. Okay, so there is no slope. Y equals 3 is a constant, but that's a horizontal line, and the slope is 0 because it's as if it says y equals 0x plus 3. So you don't go up or down at all, which means you're on a perfectly flat horizontal line. So x equals is a vertical line, y equals is a horizontal line. Okay, there's your picture of your x equals line. It's a vertical line through wherever x is 5 on the x number line, y equals 3 on the y number line, or the y-axis, I should say, and it's a perfectly horizontal line. So if I want to graph x equals 3 and y equals -2, all I'm going to do is say, well, x equals 3 is a perfectly vertical line. It goes through 3. Well, y equals, hey, wait a minute, there isn't even a y in the problem, so there's not even a slope to consider. Now, for y equals -2, well, that's the same thing as y equals 0, x minus 2, so that means the slope is 0. If the slope is 0, you're not going up, you're not going down, it's just a flat horizontal line. So here is 3 on the x-axis, and there's my vertical line through 3. That line that I just drew is a picture of x equals 3. Y equals -2 is a horizontal line through -2. So this vertical line is x equals 3. The horizontal line is y equals -2. You try the next one. Go ahead. Okay, so we realized just as before that x equals -4 is a perfectly vertical line, straight up and down through -4 on the x-axis. Why? Oh, let's take a look at y equals mx. I can't even look at y equals mx plus b because there's no y in the whole problem. There's no y, there's no slope. And y equals 5, well, that's like there's no x's in front of it, so that's y equals 0x plus 5. So the slope is 0, so you're not going up, you're not going down. It's a perfectly flat horizontal line. So x equals -4 goes through the x-axis where x is -4. There's my graph of x equals -4. X equals is always a perfectly vertical line. Y equals is always a perfectly horizontal line. Y equals a constant, a single number without an x term. So y equals 5 goes through 5 on the y-axis and a perfectly horizontal line. One more for you to try. Okay, so for x equals -2.5, that's a perfectly vertical line because it says x equals, and that's because there is no y. If there's no y, there's no slope. And then for y equals, oh, it says y equals 0. I'm sorry. I forgot to change this down here. If it's y equals 0, I go through the 0 on the y-axis and draw the line, okay? So disregard the bottom in red there. X-intercept is on the x-axis, y on the y-axis. We already know that. X equals -2.5. I find -2.5 on the x-axis. Draw a perfectly vertical line through it. And for y equals 0, I find 0 on the y-axis, and I draw a perfectly vertical line. Another name for the x-axis is y equals 0. Okay? All right, so there are, today, or on this video, we covered graphing with y equals mx plus b. We did that, I should say, on the second video. On the third video, this video, we got into graphing with x and y intercepts and also perfectly vertical and horizontal lines. Enjoy, guys. Have a good one.